Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate on the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And hello to Mark and Andy and Bronson and Paul, who's now home and I hope much more comfortable. Chris, and welcome to specific welcome to Andy from all the way from the UK. So we've got a huge program tonight, our final one before Christmas, and just a reminder for people, we're not going to be here on Christmas night.
Oh, come on, why not, Justin?
Sorry.
Priorities, mate.
Sorry. And I have Ben, VK7BN.
Yep. Hello, all.
Ben has been our studio audience the last few
weeks.
Few weeks. So I've managed to convince Ben to be in the studio, and we have a wonderful blast from the past,
which was your fault from last week. So
hey, before we get underway, I'll just do the acknowledgement. I wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge and the culture and hopes of Aboriginal Tasmania. So the very first thing I was going to go through to kick us off with our before Christmas extravaganza was, now I'll just go to, that looks about right. Tony, VK7XTC put us onto this. Now, there is a wonderful station called OF9X who is out there. There's a whole bunch of operators from operating from Finland. Of course, which is the land of Santa Claus.
Yeah.
So, and Tony was privileged to contact them and got this wonderful QSL card. And if you want more information on this, just put in OF9X, and it will send you off to their QRZ page, which has this wonderful QSL card and a whole. If I click out of here, going backwards, here we go. A wonderful QSL QRZ page around wishing you Christmas 2024 from the far north in Finland, and they're operating over the Christmas season. There's a whole bunch of operators, and the one I picked out here, plus our Ukrainian guest who is Alex. OH5UH UY, sorry, UT5UY. you can contact a maximum of 16 Santa operators on a variety of bands and modes, which make up Santa's running total score. So you can, there's a bit of a competition going on, etc. So there's a wonderful QRZ page. I'll put a link to it in the video description. But yes, it's I thought we'd start off with that as a bit of a Christmas wonderment. So yeah. Now, last week I finished off with a couple of manuals which were 50 in 1 and 10 in 1 electronic project kits that I've had in my past. Now I didn't actually have the actual kits, but what I did have was the manuals. Ben piped up and said, "Oh, I think I can actually get you a kit."
Yep.
So if you'd like to hold that up,
I can
Ben,
try and hold up what we have, like so.
and we'll zoom in. Hang on, we'll come around a bit and try and not get the antenna in the.
Yep.
There we go. Now just describe what you've got in your hands.
So this, I think, was given to me like on somewhere between my 12th and 15th birthday, I believe. It's a science fair 130 in 1 lab. So these were sold by Radio Shack or Tandy,
I love it.
as it was here in Australia. And there's actually a different brand now. They're sold under a different brand again, which have come and gone. But yeah, they're out there. And so what I have done here, with Justin having spoken about this last week, was made a little weekend project to put together the crystal set project in off this. And so I'll hand it over to Justin here.
There we go.
He's got the manual.
I've got the manual. So this is the opening page of the manual, which gives you that close-up view of the board. Can I just say, this was a pretty upmarket one, because this one actually had ICs. So,
as I recall, I think the 200 in 1 had a VU meter on the side of it. So
and it's got a 7-second. This one's got a 7-second display. So it's got a bit of logic, a 7.4 chip on it, and also an op-amp chip. Now, so this is the electronic version of the manual.
Yep.
Now, where was the?
So I think it's section 9 or it's page 133.
Ah, okay. Let me zoom.
Or you
zoom
can
down.
take this and Elmo it.
Ah, okay.
That's
Hang
why
on.
I printed these out. Was
Yeah, that's
because-
probably easier. And then we can zoom through. Then we can zoom through the. Now let's go back over here, and if I do the magic here,
Ooh,
oh, we were already there.
there we go.
Now what? So we are looking at the number
Focus.
110 project, the crystal set, simple diode radio. So that's what you've got
Yep.
on the. So we're looking at.
Can we focus that up a little bit, just?
Not try.
Fully?
No, I had trouble with this last time.
That's
Hang on,
interesting.
let me take my hand out. That's as much as we can do.
Yeah,
actually,
okay.
that's.
Interesting. We might need to adjust that at some point.
Yeah, we might actually. Hang on. Can I come up a bit?
Or do we need to go down and then...
Can we go down and then focus? No, we can't. Hang on. What can I do here? No, I think that's the iris.
Oh, good.
No, I think we.
You'll have to talk us through it then.
I'll have to. Well, I'll truly talk you through it. I just can't go quite as far on that one.
Yeah.
Anyway, okay. So, well, let's. I'm going the wrong way. There we go.
Oh, there we go. That's readable.
So we've got, this is the diode crystal set. So instead of using a crystal, it's using a diode. You've got your, let me grab a pen. You've got your tuning coil, so on a ferrite rod. Yes, ferrite rod.
Yep.
Yes. You're using part of that, which is in parallel with your tuning capacitor, your variable tuning capacitor, which is a broadcast tuning capacitor.
Yep.
You've got the ability to pull it one way or the other, just slightly, using a 10 puff or a 100 puff capacitor here with a little switch. Now, each of these points are actually little springs on the. So all of the, where there is a number, there is a spring. So and then tapped off of that, the middle of that coil, we go to the crystal detector.
Yeah.
Which is the germanium diode, so the GE germanium diode, so 0.3 volts dropped across there. You've then got some frequency adjusting circuitry, as in a capacitor and a resistor, which goes to the very high impedance, as in megohms, crystal earpiece to receive the wonderful ABC AM broadcast stations.
I found I can get both ABC and, unsurprisingly, Radio National, because they're the two biggest kids on the block.
At the same time, or you can actually tune them?
Just can actually select them.
Woo. Selectivity. Now, for our foundation licensees, what are the three things that we need in a receiver? Selectivity is one of them. Sensitivity and stability.
You might struggle with some of those with this crystal set.
That pisses me off that we can't actually. So, what is the next project? Because Ben's put them in a bit of a sequence here.
Yeah, hang on.
Has put them in a bit. Actually, we should have. No, hang on. We should have.
Actually, that's a little too far.
That's a little too far. Just go.
Yeah, you're pretty close.
You're really, really close, because these can actually.
We're nearly there. There you go.
There it is. There. Okay, let's just do a transition here. That's a better document. So that was the one we just looked at. The next one in the sequence is the next one on the page, I think. 2 transistor radio. So you introduce some amplification in 2 stages here. So a bit of RF amplification and a bit of AF amplification. So RF and audio frequency. Introduce a plus and minus supply in here using the 4.5 volt the 4.5 volt capacitor batteries, which are on the back of the box and are actually tapped, I noticed.
Yes.
So you can get to 1.5, 3, 4.5, etc. So that's pretty cool. So that's the 2 transistor. Then we go to the wireless code transmitter. Okay, so we're talking transmitter here. Does it say which? Using a common AM radio, so we're at AM frequency, so 500 hertz to 1.6 megahertz, 500.
Probably all across that band too.
Well and truly, yeah. bit of a spark gap equivalent.
Yeah.
AM radio station. There we go. So you're using the speaker as the microphone. You then go into a couple of stages, some matching antenna. You're using the full range of the battery. Yeah, AM. I love it. Going out, I assume, on AM frequency, so, and fairly wide and broadband. I think I'm probably right there. An operational amplifier radio. So instead of using the transistors, we're using the 728, I think.
Yep, 728.
728 op-amp IC. Now, you're also using the detector. So there's the germanium diode in here as well. So what we are talking about here is an AM radio receiver.
which goes straight into the op amp, gives you... Okay, the input resistance on the negative side of the op amp is 1K, and the feedback resistor is 100K. So, that is 100 to 1 gain. And then into your impedance matching transformer and into the speaker. And that introduces also the batteries in a positive and a negative configuration. So there you go. Now that's... And a dual pole single throw switch. Woohoo! Oh, now, where did we get to in the...
So
let's go back a bit here.
That is about where we're at. But there was only half a dozen of them.
There was a code practice oscillator,
yeah.
which is further up.
Up.
Back, and
there it is.
There it is. With tone control. Oh my god. So, what we've got is, an oscillator. A transistor in
really? No.
oscillation.
An oscillator when it's
with a feedback, a 47K feedback resistor then goes through a 50K pot. So it gives you a bit of control of the feedback. Both batteries, and you're keying the battery supply to the oscillator. So, and then an impedance matching transformer. Oh, very good. I love it. I love it. I love it.
So only half a dozen of the 130 projects, but I'm sure we don't want to get into making LED flashes and woodpecker sounds and all that sort of stuff.
Well and truly.
Let's
go back here.
One of the interesting things about this book, and if you go right back to the beginning of the book, Justin.
Oh, yes.
Is that it actually starts off with actual pictures of the wiring on the board for the first dozen projects.
Ah.
So...
it shows you how to do it.
Yeah.
So all the different components. And
so there, here we go.
Ah.
But it only happens on the first.
So let me just go here and here. There you go.
Yeah.
So it actually shows you how to connect, gives you a bit of an idea, and the wiring. It gives you the wiring sequences. So 1 to 29, 2 to 30, etc., etc. So you find the relevant numbered springs, and you bend the springs back and put the wire in the spring. Electronic woodpecker. Have you ever heard a red-headed woodpecker chirping? Well, there you go.
I bet you, after building this circuit, you still would never have heard about a red-headed woodpecker. So,
I love it.
So, anyway, that's my show and tell, given talks
now,
last week.
Ben, I've got some questions for you. When did you actually get this particular kit? When do you reckon you actually got this?
My best guess is mid-90s.
Okay. 94, 95-ish.
Actually, hang on. No, I tell a lie. Probably early 90s, actually.
Okay.
Because I reckon it would have been early-ish high school, maybe end of grade 6 at a guess. It's been so long.
And who gave it to you?
That would be my mum. I'm pretty certain it was a Christmas present. So.
And at this stage, was there any hint of amateur radio?
I am trying to think.
Anyone in the family?
No. Having said that, I can't... certainly one Christmas it was this.
Okay.
But it wouldn't be long after, on a Christmas, I ended up with a shortwave receiver. Either the following year or...
Okay.
Probably in the following year or two. I got one of those. Probably a lot of people might remember the Dick Smith Electronics multi-band shortwave receivers, and it had about 6 bands available on it. So and don't have that radio now. It was also the first radio I used to get VK7SA Morris Potter with slow scan TV nets. I would plug a circuit board in to that, which he had designed.
That is a blast.
Yeah. It would just take the audio, convert it to a serial signal, back into my 486 computer of the day running JV fax. There are some magic keywords there for some people who've been around as long as we have.
Very triggering. Very triggering.
Yes. So that was...
Okay.
So, radio was starting to happen about that, early teens. And then definitely late teens, so 95, 96 was when I was first introduced to it by Charles Silent Key VK7PP.
Yep. Yeah.
Because
Okay.
Charles built the dinky that I used to sail. So
And
Charles Payne, yeah.
I actually have Charles's ATU that I'm still using.
Yeah.
So there you go. Fantastic. His spirit lives on.
Yeah.
Now, favourite project?
Oh, don't ask me that.
There's 130 to choose from.
I know, and I the first time I looked at them in about 30 years was on the weekend. And so, yeah, no idea these days, but like I definitely remember fiddling around with the radio stuff a fair bit,
Okay.
trying to get more audio out of the crystal set.
Yep.
So,
Okay.
yeah.
I love it. Absolutely love it.
All right.
That is fantastic. Thank you very much, Ben.
No worries.
We will certainly continue this theme in some way, shape, or form.
Between that and packet radio, yeah. That's
Well,
a whole different thing.
the packet radio actually is still going wonderfully right at the moment. There are
Don't I know it?
there are more people getting involved,
Yeah.
and more packet stations
Yeah.
on air. So
So other than the fact I think my radio turned itself off in the last 24 hours, my packet node's been up for
okay,
a good week.
okay,
It's doing the NetROM thing
Yep.
between me and Danny.
okay.
So,
Yep.
and I think Danny has a gateway across the internet to the 44net, which is why we can see all the international nodes as well. So, like, there's actually a lot of fun stuff out there for people with packet radio.
Absolutely love
moment.
it. Absolutely love it.
Except for those people who insist on trying to use Baycoms. I just have nothing but trouble.
It's sitting there. It's sitting there. I have actually re-imaged a notebook, an old notebook I had, with Dragon OS, the latest version of Dragon OS,
Yep.
which of course has Direwolf and a whole lot of other things
Yep.
on it. So that's the machine I'm going to be using with the modified Baycom. So bringing
Yep.
the Baycom back to a normal arrangement,
Yep.
not a normal arrangement, a standard RS-232.
Yeah.
And that's the one I was going to. That's my project over the Christmas period. So
Well, you know where to find me.
yep, and there are more stations to contact.
So, yeah, I think Lance 70O's in the process of getting his set up.
Scott,
Scott HSE's back there, of course. Now that we've got some connectivity between Scott and myself, and Scott can get to Danny.
Yep.
Through me. So
Okay. Well,
it's,
can I just say that is exactly what packet radio is about.
Yeah,
It's
giant mesh networks.
correct. It was the mesh networks before mesh networks,
Yeah.
and the internet before the internet.
Yes.
I love it. And I used to have a 44. I actually got allocated a couple of 44 IP addresses.
And you can still get them pretty easily too.
Well, there you go. I love it.
And then you can install
God.
a 44net modules into Linux or your
Okay.
router. Like
Okay.
apparently there are modules.
Well, you can route.
Yeah,
You can then route.
yeah. You know the MikroTik routers actually
Yeah.
have a module to plug in AX25 over IP, so you can actually like for some of us, including here at East, we use a brand of internet router called a MikroTik.
Yep.
And there
Great little routers.
there are modules to plug them straight into the 44 AMPerNet, and they'll route the
I love
44
it.
stuff.
Absolutely love it.
So, like that might be my Christmas project. So
Oh.
we're going to do it like it's 1989, Justin.
Party like it's 1989.
Yeah.
I love it. All right.
All right.
Thank you very much,
No
Ben.
worries. I'll go back to my pre-allocated seat on the other side of the camera.
Oh yes, move whatever you have to move. Fantastic. All right. Can I get you before you go to your pre-allocated seat, your reserve seat? Can you go and grab Ron for me?
Ron, I can go and get Ron. No
Because sitting next to, can I just say, sitting next to Ben is the next thing we're going to be looking at, which is a QFH antenna. While while we're doing that, and thank you. Hang on, I better check the chat. Chat. Evening. Oh, thank you, Mark. Yeah, I like this. This is one of my favourite T-shirts. Merry Christmas. Oh, David. Yep, and Merry Christmas to you as well. And here, let me go this way with our newfangled camera device.
Look at that.
And I welcome Ron VK7WRC World Rally Championship. I like that. To the studio. Hello.
Hello.
Merry Christmas.
Yeah, Merry Christmas
All
to
that
you.
season's greetings and all that non-denominational stuff thing. Now, the reason that Ron is in the studio is something that's sitting next to him, which is a Quadra Filiar Helix antenna. Now, this particular one is tuned for about 401 megahertz, which surprisingly is the weather transponders, the weather weather balloon that is released twice a day, once a day.
I thought it was once a day.
Once a day. From down here at Cremorne, which used to be the airport, it's now moved down to Cremorne. There's a whole bunch of amateurs in the club who are all tracking the weather balloons, hoping that the weather redirects them back to us. Instead of one of the things that the guys in the northwest who are also tracking. Let's zoom out here. There we go. And we bring it all in. You can actually, with this camera, you can see a whole lot more of the studio, which may or may not be a good thing.
It's good that it's tidy.
It's great. We've got even
Definitely
audience.
a very tidy studio.
We've got audience members. We've got enough room for audience members. Now, so I was going to go through a few bits and pieces just before. So, one of the things that, and let me do that transition. Okay, one of the things I came across was this wonderful LibreSpace article. It's actually quite old. It's December 2017, where Sirligas, whoever that is, who's a LibreSpace core contributor, so somebody who contributes quite a bit to LibreSpace, came up with a 433 megahertz quadrifilia design that he made up using FreeCAD, the 3D printed elements, the top, the middle and the bottom elements, that fits over PVC pipe. And I looked at this and I went, okay, I have really wanted to experiment with QFH antennas because I was really into satellites a long while ago. I'll say that, a long while ago. And I built some Lindenblad antennas. Now, I'm not going to go into those, but Lindenblad antennas are really, really good at low angles. Great for satellite work. And so, but at the time, I was toying with making a QFH antenna or making a Lindenblad, and I ended up making Lindenblad antennas. This guy put up the QFH antennas, the design, the 3D printed design. Now, our guru here in the studio, which is Ron, is really into 3D printing at the moment. And so I whispered in his shell-like and said, how would you like to print this for me? And he embraced the project.
Yeah.
Now, the first thing that we had
the missus probably wasn't too happy. But
oh, not him. One of the first things we had to do was this particular design that he put up here was actually for 433, so the LIPD band. And we were looking for one a bit lower down, so a slightly bigger version of this. And so he gives the website that he uses, and I'll put all these links in the broadcast notes. All these links about okay, and calculate. all these links. So you put in the design frequency, the number of turns you want, the length of one turn in wavelengths, the bending radius, which is
3 millimeters. We
three
did.
3 mil. We realised after
And-
we
Conductor diameter, I think
Oh.
we did probably 3 millimeter too, did we?
yeah, but which I don't think it's
I think
quite
it's
there.
probably
but
closer to 2.
yeah. So let's put 3 in there.
That's
'cause
what
that's
we
what we
did.
calculated
Yeah.
on. And the width to height ratio, which stays at that. So what it gives you is the large loop parameters, which is the large loop is, you'll notice
Outside.
the outside loop, and then the smaller loop, which is the inside loop, slightly smaller. So Ron, take us through what you did, because you did some scaling here.
Yes, so the author of the site provided the STL files,
Great.
well, the 3D files, which you then slice
Okay.
with the slicing program, and then give that file to the 3D printer, and it prints it. Now, depending on the slicer program that you're using, the one I'm using is Prusa Slicer. It's free, and there's quite a few out there. When you bring the STL file into the slicing program, you have a scaling. You can adjust the scaling in percentages.
Yep.
And using the figures for 433 and 400 megahertz, I just worked out the percentage difference between them.
Yep.
And adjusted the scale to make this bigger, which works well as far as the dimensions go for the wire, but a side effect is when you scale it, everything scales. So we're under the impression, his dimensions were 16 millimeter, I think, inside diameter of 16 millimeter.
So the hole in the middle
for the pipe.
for the pipe.
Yeah, so when we scaled it, then that changed. It was no longer 16 millimeters. Have you still got the spaces? Anyway,
Yeah, they're
yeah, it doesn't matter. Yeah, so
Ron printed some little
yeah, so we
spaces.
printed some sleeves to adapt the bigger hole to 16 millimeters, and I thought, oh, yep, that should work. But it turned out that the pipe is not 16 millimeters.
Well, it's sold as 15 millimeter pipe from our company with the big B on it, but the problem is the 15 millimeter pipe is 18 millimeter internal diameter and 21.5 millimeter outside diameter. So yeah.
So it would have been good to know the proper size. But, one of the artifacts or the design of 3D printing, instead of printing solid, which consumes a lot of filament, you go through your filament like crazy. You have an infill where there's sort of like little air gaps in there to cut down. The outside's still solid, the shell is solid, but the inside is an infill. And this is like a square cross-hatched infill that's inside here.
Yep.
So what happened was Justin had to drill it out a bit.
And I'll because let me go up a bit here. There we go.
Look at that.
Now
I'm just impressed by your lathe.
that's a 4-jaw chuck, so you've got to end up centering it. So that's easy. You center it, and then that's a boring tool, so it goes in the inside and bores it out to 21.5 millimeters. But of course, in boring it out,
Yes. However,
Yep.
I'll jump in because just so happens the one that you've put on there, the first one that you bored out, I looked closely at the design and I can see that there's horizontal wires
There you
going
go.
through the middle. Yeah, so
Yeah.
we're talking about down here. There's a wire that goes through it and over this side as well.
and then there's one that goes underneath. So
Yeah.
there's one that goes underneath and through, and then there's this one at the top, which is the small loop, which goes through here all the way through.
Wasn't there a bit on the top as well?
There was,
Ah, okay.
that's actually a bit of feedback.
Right. So when I saw that, I thought, so if he's going to be putting wire through there and wire through there, that needs to be strong.
Yeah.
So another feature of the slicing program is as it's 3D printing from the ground up, from the bottom up, you can choose layers and change your infill.
Oh,
So what I did,
okay.
from this horizontal surface here upwards, because it's infill in here, but
Yep.
from there upwards, I made it solid.
Yeah. Okay.
So, because I wanted that to be strong, and I
Yep.
wanted that to be strong here.
yeah. No.
Yeah, but with these, I didn't do that.
Yeah.
And with that one, I didn't do
No.
it either.
And that's fine. That worked. Here, literally, because you have to put the wire through, and the wire needs to be straight.
Yeah.
Then you bend the wire up, and as soon as I bent the wire up, it cracked both of them off.
Oh, so it wasn't strong enough.
Correct.
Okay.
It would be better to actually put more, like make that block longer
Right.
along with
Yeah.
the hole through it.
Yeah.
But that's not
Alright.
not an issue at all.
Yeah.
And you can see there are two cable ties on there.
Yeah.
They do the job.
Yeah.
Well and truly.
Yeah. So we're at a disadvantage because as you were bending the wire, and because it's laid horizontally,
Yep.
it's going to crack along its
It's
Yeah.
mating surfaces.
Yes,
And
yeah.
you can see that.
yeah.
And in fact, can I just say, when I was boring out this top one, I cracked that sleeve off in
Okay.
exactly the same fashion.
Right.
That's why
Yeah.
that's araldited on.
Ah,
It's actually
okay, I saw the araldite there,
resined
yeah.
on.
Yeah.
Well,
Well, boring shouldn't have had to have happened.
Yeah.
Yeah.
Yeah,
So
yeah.
we can get that to decimals of millimeters in
Yeah.
accuracy.
because
Yeah.
one of
Anyway.
the issues with boring it out was I hit the infill.
Yes.
I went through solid, and I'm now
Yeah.
into infill, which
Yeah. Because the walls can be made thicker.
yeah. Okay.
But I didn't anticipate.
No,
that.
no.
Yeah.
This is all learning.
Yeah.
This is
Yes.
all well and truly learning.
We'll know for next time.
Correct. Now, the other thing I'll just say here is I used the calculator measurements for the piece of wire and cut it off, and then what you actually do, the way that you put this together is there is the smaller loop, which is this one through here, and then there's the longer one, and they do a 180 degree turn. So from here, that wire ends up over here, and you then join the end of the long one to the end of the short one, and vice versa, the other end. So it is one big loop, effectively, with two helixes in
Folded
it.
over.
Correct.
Yeah.
So I did that, and
It's one of the waveform doesn't get dizzy. Actually, it does.
well, it's good for circular polarization.
Yes.
So a fantastic space satellite antenna.
Yeah.
But when I connected it up, and then I did a NanoVNA, and I'll show you the NanoVNA in a minute.
That'd be good.
But when I did it, it was 378 megahertz. And I went, oh, well, at least it's low, which means I have to cut some off. It's not, 420 megahertz or whatever. So pretty close. So I actually cut off a good 10 mil off of each end. I got a bit brave, and I cut off 10 mil of each end. And thread it through, because there is a little bit of leeway here with the twist. I rebent it over, re-terminated it, and we were at about 399 megahertz. And I sort of went, do I try again? And I went, yeah. And I cut off probably about maybe 4 mil off of each, and then terminated it, and it's come up at about 400 to 401, which I just went, no, I'm not touching this again. So we can show that.
Talk about that.
Well, on the original design there was a choke. Now chokes are used to get rid of parasitic anything going down your feed line from a
Common mode.
common mode currents. Now common mode currents are only to do with transmitting.
That's right. Yeah.
So, from a reception point of view, if your coax is picking up the signal, well, your coax is not doing its job for a start, but it doesn't really matter. And so if we go to, and I head to there, okay. Now, if I zoom in, we get focus back here. We get, nice. Ooh. So you can see it's not bad. What we're looking at here is 380 to 420 megahertz across that scale. That's sitting currently at 401 at 1.5 to 1 SWR, which is that's acceptable. It is still a bit low, as you can see here. If I go down a bit, If I go to the lowest point here, we're at about 399. It's 1.4. You could probably get that better if you wanted to do the twisting or do whatever, but that is an acceptable antenna, and I'm not changing anything. So at 401, which is what we're looking at, we're at 1.5 to 1. So I don't care.
Yeah,
Um,
that's good.
Very happy with that. So yeah, that's yeah. That now. What else? Hang on. What else did I wanted to talk about here? Now, what do you end up? What do you? I'll just put that back over here so it doesn't fall off. What do you use? What am I doing here? Oh, we're on the right page anyway. Oh, hang on. I just showed all of that and nobody saw it. That's great, isn't it? We need to go to there and to there. Now, let me just do a quick recap because nobody was looking at it. It wasn't up there. So the scale on the NanoVNA is 380. Actually, it's 390. Sorry, it's 390 to 420. You can see 401 is where I really want it to be. It's 1.6 to 1, 1.5 to 1. Depends on. I can make that really, really better if I put a bit of capacitance in there. But that's acceptable from a receive antenna point of view. And it's reasonably broad, but not too broad. Once you go up a little bit, so 390, what would it be? 390, 400, 410, 420. So they're 5 each segment. So they're half a meg each segment. Yeah, I'm happy with that. I'm not going to play with it anymore. I could probably take a little bit more off and maybe make it right on 400 and make it the lowest, but I really don't care. That's doing exactly what I want it to do. So now, what do you do to receive the RadioSonde software? Now I've got here just a few. If I go to SondeMonitor, this seems to be one of the more popular ones. If you put in RadioSonde, weather balloon, RadioSondes, you'll get all of these, and I'll include these URLs in the video description. There is also a program called RS41, which is what the RadioSonde Vasala number is, the Finnish company that produce it. But this is the SondeMonitor. You put a SDR in front of this, or your receiver, your 70 centimeter receiver of choice. Lots of people use RTLSDRs. I was using a Pluto, ADLAM PLUTO on it as well. You've got a SDR front end, so I don't know, Cubic SDR or some other SDR program that you use, and then that feeds into SondeMonitor, which is this is a Windows-based program, and it gives you the data mapped onto maps and gives you direction that it's heading in and gives you all sorts of things. So it's pulling that telemetry data out. You can see here the temperature charts, etc., etc., and it does all of this. And then it also, if you click the relevant buttons, and you have a login, obviously, to SondeHub, which is the balloon tracking website, then it puts all that data into SondeHub as well, and shows that you're tracking, gives you credit for your tracking the balloon, and yeah. So haven't quite got this far yet. Only just finished the particular
So you would mount this antenna up on your roof?
Yes.
Vertically?
Yeah, as high as you can.
as it's shown in the picture because
Well-
of its
well
low
and truly.
radiation.
Well and truly.
Yeah, and you
Um,
said something about it had a null at the top overhead.
Ah, yes, correct. You're very good, Ron. Now, it has a null over the top because there is absolutely none of the radiation pattern, or there's very little of the radiation pattern that's actually above. There is some, and it would. Can I just say it would have to be absolutely directly above the antenna
Okay,
for it
yeah.
to get nothing,
Yeah.
which it won't be for very long. But it is. They're great antennas for low angle. They're absolutely fantastic antennas for low angle, and so that's one of the advantages of it. And in fact, that was the reason why I went with the Lindenblads and was very happy with them. I was receiving satellite information and data where the prediction program GPredict was telling me it was below the horizon. Now that may or may not be right, but very, very low angle. So so I'm really interested in how this performs. So yeah.
You were also mentioning you thinking about putting it in a tube.
Yeah.
Yeah, a bit more protection.
Bit more protection, and can I just say, be very, very careful with the plastic that you use. The PVC. Some PVC actually contains, and I think I'm right here, it contains lead or contains some sort of metal. And the easiest way to work it out is cut a little bit of the plastic off and very carefully put it in the microwave for a short while and see whether the plastic gets hot. If the plastic gets hot, don't use it because it's got metal in it and it will affect it. Like if you then put a metal tube over the
Yeah, well, that goes the same with your pole
Well,
as
true.
well. It'll affect your radiation pattern.
Correct. So just be a little bit careful of that. I actually haven't done the microwave test with this, but I can cut a little bit off the
I
other
reckon
end.
it'll
And
be right. White
and-
will be okay.
well, yeah, I'm not sure.
If it goes,
And given they said that this was 15 millimeter, I don't believe them anything about it.
yeah.
But yeah, anyway. So and that was more out of protection than anything. You'd put it around. You'd put the tube around it. You could put a 100 mil or a larger bit of tube over it just to do a protective layer on it, and put everything in the tube.
And the other thing was the birds. Was it the
Cockies, yeah, and the various that have really, really sharp and deadly beaks that decide that they want to chew on bits of plastic and coax and feed lines and all sorts of stuff, which can be a bit of a very destructive bird. And if you happen to have a pine tree in your backyard and a flock of them land in your pine tree, well, you can kiss every pine cone goodbye on that particular. And you don't want. Can I just say, you don't want to be standing underneath the tree when they're doing it because they don't care that they're dropping all this stuff down and dropping half chewed pine cones and whatever else. So yeah. Now I've done it again, haven't I? Okay. So now, what else have I forgotten? Bonding wire lengths were different. No, I think we've covered it.
yeah.
So we've certainly got some improvements.
Yep.
Certainly got some improvements that we could do. We've now got wire lengths, proper wire lengths for that particular diameter wire. That is just. I think it's 2.5 or 3 mil. I think it's 2 mil. 2 mil enamelled copper wire. So I have a huge stock of that. So if people are building these and they need copper wire, please let me know. Don't go out and buy them because we've got plenty of it.
Overall, what was the total length of wire?
Well, I started with each bit of wire was 900 millimetres long.
So 2 pieces of wire.
2 pieces of 900 millimetre long. I cut a fair bit of that off. So you'd be looking at somewhere in the order of, I'd say, probably 800, just over 800 millimetres.
2 lengths of 800.
The long one would be just over 800 millimetres. The shorter one would be just under 800 millimetres.
Yeah.
But you need to do I did a rough calculation at that and paid the price because it was 378 megahertz that it was at. Sorry, it was 378, not what I said. And then had to cut a fair bit off. So and that's always fraught with danger because if you cut too much off, it's just harder putting it back on again. So
We could do an antenna build day.
We could
And make a little kit out of these things if people want to
love it,
get into this.
love it, absolutely love it, and you might be printing more than you think, but anyway.
Get a few
Now,
more of them going.
just to finish off, we'll do this. And this is, I don't know whether Jim JZ is out there.
He's out there, but there's no TV on.
Oh, okay. Well, Jim...
Should we get him in?
No, we won't get him in. We'll probably get some abuse. So another little 3D project that I got Ron to print is a cute little Morse key. I haven't put the screws in it yet, but this is hot off the bed.
Yeah.
Hot off
today.
the 3D bed.
Yeah.
Today. A little Morse key on Thingiverse, available on Thingiverse, and I'll put the link in the chat. You can see there are 2 slots in here for the spring, and then there is a screw that goes through here and holds that in place, and then there is screws on the top and bottom for the contacts, and then there is a wonderful little cord hole here that goes diagonally across to a strain relief 90-degree angle here. And then it ends up, the hole then ends up in this little gap here. So I'm looking at this probably for a SOTA key being really, really light. How?
It's 14 grams.
14 grams. So for Jim's benefit, I've now got a key that is much lighter than any other key that is out there for 14 grams. So great for the SOTA pack. Great for the SOTA pack. Great for the for operating. So I'll put that together and I'll show that at our next Wednesday experimenters group. So
Demonstrate a few tones on it.
Well and truly, I can hook it up to a oscillator and we can. And just from a size point of view, there it is sitting on my fingers, and it's about the length of my pointer finger. So there you go.
Wouldn't it be good to do a contact live?
Hey, I'm there.
Yeah.
144. We did. Poor Ben the other night. I think Jim and Ben were going to make a contact, and Ben put out a call to Jim, and I came back to him and confused the hell out of him. So, so yes. Anyway, now stay with us, Ron, because one of the things I said last week, and I got a few things together, was for those people who may be living under a rock. AI is the next best thing, which is artificial intelligence. Now, artificial intelligence on ChatGPT. ChatGPT, you can put in all sorts of things. I've got a subscription to ChatGPT, and we've got access to Copilot at work and a few other bits and pieces. So, because we're setting AI policy for the state government right at the moment. If you put in some prompts, it's all about putting in prompts. If you put in prompts, and I put in amateur radio related Santa Claus, as in clause with an E. That's my typo, not its. Image, and it comes up with this particular image. Now, this is great, but if you zoom in here a little bit, there are some issues with this image. And one of them is, what the hell is he holding? He's holding something that's got a little bit of a microphone hanging off the side of it. And then he's also got headphones on, and he's got a cord, and he's got another cord. And then there's multiple dials here. He's got a candle on his desk. He's got another candle, I assume over here. There's an absolute firestorm going on his bookshelf. And it's Santa Claus. So you sort of have to look at these things a little bit critically. Now, if you then put in, I then went, okay, the image of a normal, in big inverted commas, normal amateur radio operator at Christmas time. Now, this is slightly more believable. He's, of course, a white male with a beard. I didn't put in any of that. That's what it came up with. And he's got a sort of a steampunk version of a keyboard. He's got a bit of a radio. He's got a cord connected to something that might be a microphone. He's got a bit of a starry antenna going on here and some other bit. Anyway.
It's got a big waterfall too. Look at the size of that waterfall screen.
Yeah, well, just huge. Okay. Now, then I put in image of an abnormal amateur radio operator at Christmas time. Here's what it came up with. It's the elf on the shelf talking to whoever. I really don't know what this little car here is. I assume it's a present, and they've got a reindeer, what looks like a female reindeer on top. I'm not sure. Got a bit of a loop antenna going on here and some neon stuff going on. So, okay. And then the image of a normal amateur radio operator's house. So this is that is literally the prompt that I put in. And so we've got, antennas on the roof. That's what you'd expect. You've got RS3, and I don't know where it's got RS3 from, but and he's got all his equipment on the veranda. I love it. I absolutely love it. And then I said, okay, image of an abnormal amateur radio operator's house. And we've just got speakers all over it. We've got dishes. We've got all sorts of things. And it says Ham Radio HQ. Now, the big thing about this is it's got Ham Radio HQ correctly spelled. One of the things about AI is it comes up with some really weird wording. And I'll show you an example in a sec. Now, I then put in image of a fanatical amateur radio operator's house. And guess what it came up with? Without any prompting, always on air. And just off the show, like monitors, wall of television monitors, wall of stuff, dishes all over the place, antennas everywhere. Now, image of a fanatical amateur radio operator's house at Christmas time. Now, this is where it goes a bit wrong, because it's Merry Ham with 2 M's.
Very handy. Oh.
Merry Ham, and I think Christmas is underneath there. If you look really, really closely, yeah. Ham Christmas. It's got tinsel, it's got the tree, it's got candy canes, it's got the obligatory ram, which of course is probably an American amateur radio operator's house at...
Some of them look like toroids.
Yeah, well, they're actually good pickup there. So the candy canes are actually circles, so yeah, maybe he's using them as ballons or something. Christmas ballons. He's got all up his tower here. So anyway, then I went image of a inclusive and diverse Santa Claus operating amateur radio. So this is taking into account that most of the images that the large language model that ChatGPT uses are white Caucasian males. But this is where it goes a bit wrong.
Ham is spelt wrong.
Well, it's Horm Radio Section. We do have a dark coloured child in there. We've got a little girl in there. We've got some creepy Santa Clauses around the place. But it's just bizarre. And amateuration. Yeah. Amateur hasn't quite got the middle words right, which is the 2 letters that everyone gets wrong. Yeah. Ration, there's a map there, there's ham written on it. There's a lot of time zones, they're little clocks. So, okay, it's got the time zone thing going for Santa. He's got something that looks like a Zoom recorder as a microphone. And this little kid's playing with the Christmas lights. So, probably going to get himself electroluxed. So, now the second to last one here. Image of Santa Claus falling down a chimney with an amateur radio operator trying to carry a radio. This just becomes even more bizarre. Because
I think it knows that that Santa can't come down the chimney because the fire's going.
Yeah.
So it puts Santa on the outside with a ghetto blaster.
Sort of a radio.
And we've got somebody who looks like Santa sitting there with a white beard, looking very Santa-ish, in front of I assume, a radio set that looks like it's out of a steampunk movie. So that just got a bit bizarre. And then I thought, okay, let's see what ChatGPT thinks is a typical amateur radio set. Now, this is not bad. This is actually not bad if you look at this. Got a clock, got something, got a world map, got a waterfall, got some interesting radios, got a radio that does look vaguely like a radio, even though you can't read the frequency. You've got a microphone that looks a bit like a mobile phone from the 80s. The cord wound up, with absolutely not connected to anything. Then I went image of an atypical amateur radio set.
Oh.
And I went, yeah, this is more like what I'd expect from AI, which is just, yeah, okay, neon lights. There is a microphone there, though, that's got a little antenna on top of it. And then this is where it just gets bizarre. Image of a typical amateur radio set, including a Morse code key.
Ooh.
It doesn't know about Morse code keys. Because this thing here, I think, is what it thinks is a Morse code key, which may or may not be a keyer, but it definitely doesn't look like it. Or this thing here may be a key, or that thing there may be a key. So...
definitely no 3D printed ones.
Correct. An image of an amateur radio operator operating Morse code with a Morse code key. Now, we've instantly flipped to a defence operator, which I found
Morse
interesting.
Using
A Morse code keyboard. Could be a keyboard. Morse code keyboard. So, okay, that's a bit interesting. So then I said, okay, what's the image of a Morse code key? It doesn't know about Morse code keys at all. This is
says course.
a course code
Course
key.
code.
Course code key. Then I went, okay, give me a keyer. Morse code keyer. Doesn't know about keyers. That's not a keyer at all, and nothing looks like it. Then I went, what's an antenna tuning unit?
That's close.
That's a box with ATU on every knob. So, and then, okay, image of a Yagi antenna. That's not bad. We're getting there. Doesn't know about Yagi antennas. So, that's, I just...
Pretty amazing.
Anyway, bit of AI shenanigans. It was just bizarre. Absolutely bizarre. So let me go to... No, I don't want to restart.
Don't restart Firefox.
Hopefully it's going to open all those tabs up for me again. We'll just do a space weather report. Now, Ben has sent me a space weather report, but I've got to go. I know how I can. Here we go. Here we go. Let me go down. It's quite warm in here. You might want to open the door, right?
It's quieting down out there.
It has. Go past all my fanatical amateur radio operators. We probably need a fan in here, don't we? Even though we've removed equipment from here.
Heat and noise equipment.
Oh no, there is a HF fade out warning. Okay, for the 18th, 19th and 20th of December, R0, R1, chance of an R2. So effectively, their advice is degraded HF propagation conditions expected. If comms difficulties experienced, try a higher frequency. So there is a HF fade out warning at this point in time from the Bureau of Meteorology Space Weather Forecasting Service.
Could that be an aurora coming along?
Might be, might not be. Let's look at the KP index. Probably not. The Australian KP index is at 3. So yeah, probably not.
The auroral oval tool, yeah, we're not going to see much of that. So anyway, so now future training and assessment courses, please, we've set out our training and assessment dates for the foundation, which starts on the 22nd of February, and our standard advanced and regulations assessment day starts on the 29th of March, so they alternate month in, month out. Now, just a reminder, what I said at the beginning, there is no Wednesday Experimenters group night on next Wednesday, which of course is Christmas Day. So Merry Christmas to everyone, and we'll be back though the week after Christmas. We'll actually be back, so our last one for 2024, so that'll be a big celebration night, I reckon, of Wednesday Experimenters group nights. And then just a reminder, and then we continue on in January. On January the 19th, there is the mother of all car boot sales and sausage sizzle up here. And just a reminder, Reist is selling 8.1 metre and 5.4 metre collapsible aluminium collapsible antenna masks. Now, can I just say, they are exactly the diameter that they advertise, both inside and out. So Capral have got their act together, Bunnings haven't. So I'll probably be sued for that, but anyway. We'll be selling them for very, very reasonable prices. So and you'll be able to buy a snag, etc., etc. So that's our lot for tonight. Thank you, Ron, for coming along, and certainly if we zoom a little bit to the side here or zoom out,
That was a learning experience. That's what it's all about.
Oh no, well and truly, and my intention is to get that up and going and test it over Christmas. So get it up on the roof, get it as high as I can, and do some testing around whether I can see. The problem I've got where I am, those balloons will have to come up over the mean range, get higher than the mean range by the time I can see them. If they go to the southeast, I'll be able to get them quicker. But if they happen to go to the east and stay low and then go high, I'm only going to see them quite a distance away. So it'll be interesting to see what I can see. But anyway, that is fantastic, Ron, and thank you for doing all that printing. It's fantastic, and absolutely love this. So yeah. Okay, that's your blooming light. Have a great Christmas. Have a safe and relaxing Christmas, please. And we'll catch you in 2 weeks' time, in just the week after Christmas. 73 from me and
73 from me.
Cool. And we'll see you next time. Cheers.